Okay, so that's what I would do if I just wanted to print out to the terminal. What if I want to write that information to a file instead? Oops, well, in Java, the thing that does that is called a print writer. And what do you think I specify inside the constructor? If I want to write this stuff to a file, a string which contains at least the name of the file. Okay. What's that .txt thing there? Why is that there? So you know what kind of file it is. Okay. So if you're living in a Windows world, what they originally did was they had that 3-character extension that allowed you to say what type of file it was. What do they do if you're in the Linux world?
It's on like a program-by-program basis, and you don't need it.
We'll go here and do an ls. So in that case, notice I have some stuff with extensions on it, so it knows what out.ogv is. So just let me find one that's something else. What have I got here? We'll go look in my my Git folder. Oops, didn't do that right. So there's what's in my Git folder. We'll go look in Git /. By the way, there's your metadata that we were talking about earlier. There's Git Comp132. Let's just go look at /lab4. We'll keep working our way down. There's src. What's that thing called, by the way, that I was just building? There's another thing that's different about files. They all have a path associated with them typically. So there's some sense that there's a hierarchy associated with it. So I can do, let's just do race test here. Okay. So Linux has this file command, and the file command will actually try to tell you what type of thing it is, regardless of whether or not it actually has an extension. So in a lot of cases on Linux, we don't bother with the extension at all, because you can always use the file command to find out what something is. Okay. But those all happen to be text files. Okay. So let's go make a print writer here. And let's do the import statement. By the way, almost all of the stuff that we're going to use is in the Java I/O library. And when I try to do that, it gives me this nasty little message. We said files are different. The thing that it's upset about in this case is it's saying something could go wrong there. What could possibly go wrong with trying to make a file? There's already one there. I don't have permission because it's not, the current directory isn't the directory that I happen to own. The disk is full, so I can't use any more space on it. So there's all sorts of things that could go wrong with that. The two options that you have there are really find a way to deal with it by figuring out what the error is, or the second option is, oh, I'll just send that up to a higher authority and let them deal with it. My boss, right? I don't know how to deal with this here. My boss asked me to do this. I'll get them to deal with it. In this case, we sort of are the boss. The main program is sort of the boss, but what we can do is we can add that onto the front, and that throws there just means that it might be that for some reason there's an error, in this case a specific error, file not found exception, which actually encompasses a bunch of things. And I'm just saying, I'm not prepared to deal with that error. In this case, because it's the main program, if I just punt and say I don't want to deal with the error, the program will just quit. Okay? So I'm not going to worry about that sort of error, because in this case I just know it's not going to happen. We'll talk about the other option of dealing with the error later. So what I can do now is I can say writer dot, oh look, writer dot println hello instead. Okay, and the difference between the two is that this by default writes out to the terminal. This one says I want to write that information out to a file instead. So let's just write another line of stuff. So there's now 2 lines of information. Anything else that's interesting about files? How many files do you think I can open like that with variables? Okay. Well, you would think as many as you want, but the problem is that's an object, and you can think of that object as needing some space to keep track of stuff, and actually the operating system also needs some space to keep track of information, in particular about where's the end of the file in this case, so that when you say write, it knows to write some more stuff at the end. And so what it does is it keeps some data about what's going on with the file while the file is in use. And so it turns out that there's usually a limit on most systems as to how many files that you can have in use at one time. Originally on Unix systems it was 16. And input, output, and error on Linux counted as 3 of them, so you were actually down to, unless you did something, you were actually down to about 13 files that you could have open at the same time. And when you tried to open the 16th or 17th file, whatever the number happened to be, then all of a sudden when you tried to do this, it would go, no, I've got no room, you've reached the maximum. Okay? On modern systems, that maximum is a lot larger. I think on my Linux system right now, it's probably 1,000 files that you can have open at one time, which is just a huge number. But still, the tradition is after you're done with them, there's a close command. And the close command just says, I'm done. Okay? And really what the close command is there for is so that people who are like the system can turn around and release the information that it has about that file so that it can reuse that slot or be able to open other ones later. Okay? So that will end up hopefully writing out the file, so we'll just run the program. And there's the original hello, and notice that the other stuff didn't print because it got written to the file. Where's the file? When I said my file.txt, where did it put it? There's this notion of the current directory, right? So since I didn't put a specific path name on here, it's going to get created wherever this program happens to be running, whatever it thinks is the current directory, which in this case is probably, if we go use a regular file browser and have a look here, if I can find one. So here is /home/Daryl. It's actually going to be buried in my in my Git folder, Comp132. I have one called Files. Oh, not yet, because I haven't done it yet, so it's still in the other place. Comp132A. There's the files stuff. oh, look, there's my file.txt. So that happens to be the current directory for just this program, right? Because I put it in a separate folder. We can go and look at that. And if we look at what's in it with a text editor, there's the hello there. Okay, so I managed to store that information now into a file. Why didn't it appear in Eclipse? You would think that it would be there someplace. This is a case of the answer is Eclipse doesn't know. Eclipse is trying to manage that entire directory worth of my workspace. If somebody comes and slides a file into it, Eclipse has no way of being notified that that file was actually put there unless it goes back and rereads all of the information about what's in that directory to see what's there. Same as if you stuffed a file in someplace on one of my directories across the network, unless I actually went back and did an ls command, it would never know it was there. So you can force Eclipse to reread that by doing, where is it here, file refresh. And sometimes if you do a file refresh, I specifically said right mouse clicked on the files directory, then all of a sudden there it is, and Eclipse now knows about it, and Eclipse will open it as a regular file. Okay, so that's the little trick. If you don't see the file to begin with, you'll have to do a refresh because Eclipse has no idea that it's there unless you force it to go back and look again. Okay, and so now we've reached the point where we can at least write stuff out to files. So tomorrow we'll figure out the reverse. How do I read stuff back in?